In this video, I'm going to talk about Coulomb's law. Coulomb's law is useful to find force between two charged objects. Okay, so basically it tells us the relation between force and charge 1 and charge 2 and distance. Okay, so according to Coulomb's law, this Coulomb's law is almost similar to the Newton's third law of gravity. My apologies, it's a law of gravity, it's not third law. So F equal to in the law of gravity, F equal to G times m1 m2 over r square, where m1 is the mass, m2 is another mass, g is a constant, gravitational constant, F is the force, r is the distance. Okay, so this is Newton's law of gravity. Now, in a similar way, Coulomb described the force between two charged particles. According to Coulomb, that force is directly proportional to the charges Q1 and Q2, and the force is inversely proportional to the square of the distance. So basically, the force is proportional to Q1 Q2 over r square. If we remove the proportionality constant, that is replaced with k times q1 q2 over r square, where k is called proportionality constant. K is nothing but proportionality constant, and that value is 8.99 times 10 to the power of 9 Newton meter square per Coulomb square. Okay, so basically this unit came from here. So we know that force is measured in Newton. Q1 is coulombs, Q2 is also coulomb, R is in meter. So if you move this meter square, I mean, since it's R square, so it must be meter square. So Newton meter square over Coulomb square. Sometimes you can use 9 times 10 to the power of 9 Newton meter square per Coulomb square. Okay, so I mean, in the past I saw a few students are confusing with -9. That's not negative, that's a positive. This number is very big number. Okay, now there is another formula for k equal to 1 over 4 pi epsilon naught. This epsilon naught is called permittivity of free space. We're going to use this a lot in the electricity part. And when it comes to the magnetism part, we'll use mu naught, permittivity of free space. It's a constant, and that value is 8.85 times 10 to the power of -12. So k value is 1 over epsilon naught, right? So this unit is also going to be reversed. Coulomb square over Newton meter square. That's the unit for epsilon naught. It's up to you. You can use either k or epsilon naught in the future equations. As I mentioned, Coulomb's law is useful to find out the force between two charged particles. Now, the main disadvantage with the Coulomb's law is it is useful to find the force between 2 point charges. Okay, so if the charge is distributed along, we cannot find the force by using the Coulomb's law. So if the charge is all over this a wire, you cannot find the force by using the Coulomb's law. Now, at the same time, if the charge is moving, then we cannot use the Coulomb's law to find the force. Okay, so that's the main disadvantage of the Coulomb's law. So the disadvantage of Coulomb's law is it is useful for only point charges. It is useful for only charges when they are not moving. So that's the main disadvantage of Coulomb's law. Here is an example. So in physics, it's kind of hard to read the content and convert that into diagram. But in this example, it's not that difficult, so I'm going to go with the diagram. Now, a 1 microcoulomb charge is placed 2 centimeters away from a negative 1.5 microcoulomb charge on the x-axis. find the force between those two charges and how the force changes if the distance between the charges tripled. So as mentioned, I'm going to put it in a drawing so easy to understand. So there are two charges. First charge is a positive charge, Q1, which is 1 microcoulomb. Another one is a negative charge, and he mentioned Q2 equal to a negative 1.5 microcoulomb, but I already indicated negative charge there, so I'm going to make it as a positive number, 1.5 microcoulomb. I understand that this is, you must understand that that's a negative charge. Now the distance between these two is 2 centimeter. Now he is talking about find the force on each charge because of the other charges. So that's a part A. And part B, what happens if the R becomes 6 centimeters. So first we'll find part A. He's asking about force on charge 1 because of charge 2 and force on charge 2 because of charge 1. Okay. In reality, the force on this charge is same as the force on the other charge because of the other charges. So here, when I say F12, remember the important point is here, whichever number is first, I'm trying to find force on that charge because of the other charge. So F12 equal to force on charge 1 because of charge 2. Okay, remember force is a vector quantity. It is a vector quantity, so it has both direction and magnitude. In reality, I'm saying F12 equal to F21. It is only magnitude but not the direction. Okay, when you include the direction, F12 equal to negative F21 because that negative came from the direction. I will talk about it in a minute. So force, it is a vector quantity. Sorry about my writing skills. Now, so F12 is force on charge 1 because of charge 2. Same way F21 is force on charge 2 because of charge 1. Okay, now, so F12 equal to K Q1 Q2 over R square. Now, force on charge 1. Which direction this charge is going to move because of charge 2? So here these two charges have opposite charge, so attract each other. So definitely the charge 1 is going to move in this direction, right? So the direction F12 is towards right. So whenever we indicate the force, you must indicate the direction too. So K value, we take 8.99 times 10 to the power of 9 or 9 times 10 to the power of 9 times Q1 is 1 micro. Micro is nothing but 10 to the power of minus 6 and 1.5 micro 10 to the power of minus 6 over R is nothing but 2 centimeter square. Make sure you convert that into meter. 2 times 10 to the power of minus 2 whole square. Okay, so this value F12 I end up with 33.75 Newton. Okay, and which direction that force is going to be? That will be attractive force, and it's going to move towards right. Okay, or maybe you can indicate the arrow. That is the magnitude of force on charge 1 because of charge 2. Now, what is F21? F21 is also the same amount. Okay, 33.75 Newton. But the direction is going to change. Now, we are looking at charge 2, assuming charge 1 is constant. If charge 1 is not moving, which direction charge 2 is going to move? It's going to move to the opposite side. So, you can say left or you can indicate the arrow. Any one of those two is good. You don't need to show it by both. Now part B, he asked us what happens if we increase the distance to increase the distance 3 times. So now the distance is 6 centimeters. So this is q1, this is q2. So f12, the direction is not going to change, but what happens here, k times q1 q2 over r square. Okay, you can use 6 centimeter square, 6 times 10 to the power of minus 2 whole square, 8.99 times 10 to the power of 9, that's k value, and q1 is 1 times 10 to the power of minus 6, and q2 is 1.5 times 10 to the power of minus 6. That's one way to do it, but you already know previous case. Now the distance is increased 3 times, so basically the new f12 is going to be 33.75 divided by the r is increased 3 times, so it's 3 square. So we'll end up with 3.75 Newton. Okay, so that is the force value. I'm going to solve one more example in this video. The next example, we have 3 charges placed on the same axis. Assume that that's x-axis. So 3 charges are placed in the same axis, but I'm going to assume all the 3 charges, he gave us, I'm not assuming, he gave us 2 charges are positive charges and one of them is negative charge. He also gave us the distance between each charge. This is 0.35 meters and 0.35 meters distance between each charge. He also gave us the quantity q1 equal to 75 microcoulomb, q2 equal to 48 microcoulomb, and q3 equal to 85 microcoulomb. The question he's asking about, find F1, force on charge 1 because of the other 2 charges, F2 and F3. He's asking about finding those 3. Now the first part we're going to do, we need to find force on charge 1 because of charge 2. We'll find F12, as well as force on charge 1 because of charge 3. So once we find these two, to find F1 is nothing but vector sum of F13 plus F12. Okay, so first we'll find F12 equal to k q1 q2 over r square. K is 8.99 times 10 to the power of positive 9, q1 is 75 micro, and q2 is 48 micro. Micro is nothing but 10 to the power of minus 6. R is nothing but 0.35 meter square. That is F12. That magnitude I have 264.48 Newton. Now, as I mentioned, you need to know the direction. Q1 and Q2, both of them are positive charges, so definitely it's a repulsive force. This is the direction of F12. And same way, the direction of F21, force on 2 because of charge 1 is going to be in that direction. Now we're trying to find F1, so I need to find another force, which is force on charge 1 because of charge 3. So K Q1 Q3 over R square. So 8.99 times 10 to the power of 9 times 75 micro times 85 micro, and distance is 0.35 plus 0.35, which is 0.7 meter. Okay, make sure you convert that into meters. Here it's already given in meter. Make sure you add the total distance. Okay, now here this value I have 117.09 Newton. Okay, now these two charges are opposite charges, so definitely it's going to be attractive force. So that's force on 1 because of charge 3. Now, so indicate the direction. Okay, so what is the force on charge 1? F1 equal to F12 minus F13 because they both of them are in the opposite direction. So 264.48 minus 117.09. Okay, so force on charge 1 is 147.38 Newton. In which direction that's going to be? It's going to be towards the left. Same way, we'll find F2, force on charge 2. Force on charge 2 is nothing but force on charge 2 because of 1 plus force on charge 2 because of 3. So we already have F21. F21 is nothing but negative F12. And we'll find F23, force on 2 because of charge 3, K Q1 Q2 Q3 over R square. If you want to distinguish, you can write it down as 2 and 3 or 2 3 square. This value I have 299.75 Newton. Now which direction that force is going to be? Force on 2 because of this charge is also in the same direction. This is force on 2 because of 3. Because that's opposite charge, so it's an attractive force. So this is going to be in the same direction, and F21 equal to 264.48 Newton. That is also in the same direction. So F2 must be, we must add those two together, 299.75 plus 264.48, it's 564.23 Newton. That's force on 2. Force on 3, okay, if you look at the force on 3, F21 is going to be attractive force. My apology, I put it in the wrong direction. So this is positive negative charge, it will attract, and because of this charge also it will attract. So this is 3-1, that is 3-2. Okay, so both of them are in the same direction, so they attract each other. So 3-1, which is 117.09, direction is towards left, and 299.75, that is also towards left. That must be 416.84 towards left, here towards right. Make sure force is a vector quantity, make sure you indicate the magnitude as well as direction. Do not forget indicating the direction. I'll stop this video here. In the next video we'll solve a couple of more examples. Thank you.